this is how you're going to do synthetic division. So we looked at how to do long division of polynomials, but depending on what the divisor is, you can do synthetic division, which is faster than long division. So you can use synthetic division to divide your polynomials only if the divisor is in the form x minus c. Right? So this means the divisor is divided by x minus c, so x minus some number, basically, is what that part means. Okay. So here, if we look at this one, this is a polynomial, and we're dividing it by x plus a number. Okay. This would be x minus minus 3, which would switch it to plus, so it's in the form of x minus c. So really it's x plus or minus any number. Okay. So what you do is you first arrange the polynomial in descending powers. Okay. So this would be cubed, 1, and then none. So it's in descending powers, and if you're missing any power, you use a coefficient of 0 for any missing term. So because this is really plus 0x squared, we're going to use a 0 for this. Okay. Then we're going to write c for the divisor of x minus c. So from here to here, it changes from a positive to a negative. So this is the opposite sign. Okay. Then we're going to write the coefficients of the dividend. So that's the numerator in the fraction. Remember, that's what we talked about yesterday. The dividend is the thing that's being it's going into. Okay. So if we have 5 as our coefficient for the x cubed term, we're going to write 5. Then remember we have 0x squared, so I'm going to write a 0. Then our coefficient for the x is negative 12, and then our coefficient or the constant is negative 8. So we have 5, 0, negative 12, and 8. That matches. To use the divisor, you change the sign from here to here. Okay. Notice this is the factor and this is the x-intercept, or this is the factor and this is the solution, or this is the factor and this is the root. So to go from one to the other, that's how you switch. Okay. So write the leading coefficient of the dividend on the bottom row. Oops. Okay, so you're just literally bringing this number down. Okay. So then you're going to multiply your c value, right? So whatever the opposite of this number is, you're going to multiply c times the value just written on the bottom. So we're really doing 3 times by 5. Okay. And we're going to put that, negative 3 times by 5, and we're going to put that number here. Okay. And then so you're writing the product or result, it's product, in the next column in the second row. So you do this times this and you put it here. So negative 3 times 5 is negative 15. Okay. Then you're going to add the values in this new column. So add these straight down. Okay. So 0 plus negative 15 is negative 15. Then you're going to do that same thing again. So you're going to do negative 3 times by 15, which is positive 45, and then you're going to add straight down. So negative 12 plus 45 gives us 33. And then you're going to do the same thing again. You're going to do negative 3 times 33 and put that answer here, which is negative 99. And then add these straight down. So negative 8 plus negative 99 is negative 107. Okay. So the numbers on the last row are the coefficients of the quotient. Remember, the quotient is the answer of dividing. Okay. The degree of the quotient is 1 less than the degree of the dividend. That's because we're really dividing x cubed by an x, which will give us an x squared. So then what I do is I use these numbers. So we have 5, negative 15, 33, and negative 107. And since we had a cubed power over here, we're going to go 1 degree lower, which is x squared. And then I'm just going to write in descending order from there. So x squared, x, and then a number. And then this will be our remainder, so plus negative 107 over what we divided by. Okay. So this is another way that you can do division, but it only works when your divisor is in the form of x minus c. Okay. So let's set up the one down here. So we have 5x cubed plus 6x plus 8, and we're dividing that by x plus 2. So we're going to use the opposite of this. So the opposite of 2 is negative 2. Okay, if it's written as a factor, so x plus or minus a number, you change the sign. We're going to look here. I have cubed, then I have 1, then none. So I skipped the squared power, so I'm going to put a 0x squared up here to remind me. So now I'm going to put all of the coefficients of the variables in a row right here. So we have 5, 6, oops, just kidding, 0. This is why you put the zeros. Now we talked about in long division that you could opt to put the zeros or not put the zeros. Here you have to put the zeros. You don't have an option not to. So you're going to bring down this 5, then you're going to multiply. So we're thinking negative 2 times by 5 is negative 10, and I'm putting this answer right here. Then I'm adding straight down, so 0 plus a negative 10 is negative 10. Then I'm going to do negative 2 times the negative 10, which gives us a 20. I'm going to put that answer right here. Then I'm going to add straight down, so I'm going to do 6 plus 20 gives us 26. Then I'm going to do negative 2 times 26 gives us negative 52. And I'm going to add straight down. So negative 52 plus 8. Remember that we're really subtracting the 8 from 52. So that gives us 44. And it's negative. Okay. This was a cubed power to begin with, so this will go down to a squared. So this will be x squared. 1 lower than x squared is x. 1 lower than x is x to the 0, or just a number. And then this is our remainder. So I'm going to have 5x squared minus 10x plus 26 plus a negative 44 over what we divided by, which is x plus 2. Now you do also have the option to write this as 5x squared minus 10x plus 26 minus 44 over x plus 2, right? Because remember, plus a negative is the same thing as a negative, right? So this makes it nice for some of our problems to do it this way instead of to go the whole thing through long division. Okay? So let's try this one. Again, there we go. Again, we check to make sure it's in descending order. We have cubed, squared, and then none. So I'm missing a 1. So I'm missing a 0x. Okay? So to go from here to here, to the outside, since it's written as a factor, so x plus or minus some number, we change the sign. So I'm going to write all the coefficients. In front of the x cubed is an unsaid 1. So we have 1, negative 6, 0, which you cannot forget, and then 7. We're going to bring down the 1. So we do 6 times 1 is 6. Negative 6 plus 6 gives us 0. 6 times 0 is 0. 0 plus 0 is 0. 6 times 0 is 0. 7 plus 0 is 7. Okay. So we started with a cubed, so we're going to go 1 lower. So 1x squared plus 0x plus 0 plus 7 over what we divided by, which is x minus 6. So this really is just x squared plus 7 over x minus 6. Okay. That's how you do your synthetic division. Now, we have a theorem that says if you have a polynomial, which we're going to represent with f of x, and you're dividing it by x minus c, then the remainder, so like this number right here, is the same value as plugging in c in for your x, right? So remember how we used to do like f of 2 and you'd plug in 2 into an equation, so say f of x was 3x minus 5. So if we wanted to find f of 2, we do 3 times 2 minus 5, so that gives us 6 minus 5, which gives us 1. Right? So what this is saying is if I plug in the number c, it will be the same as the remainder for our synthetic division. Right? So up here on this problem, if we had plugged in 6 into here, then we would have got 7. So if we use our calculator, we can do 6 cubed minus 6 times 6, 6 cubed minus 6 times 6 squared plus 7. And we get 7, right? Which is the same, which is kind of cool. So we're going to use our remainder theorem to evaluate p of x, which is x squared minus 32 for x is negative 7. So instead of plugging in negative 7, we're going to synthetically divide. So when you have it written as x equals 7 instead of x plus or minus your number, right, to go from here to here, we have to change the sign. So if it's x equals, you keep the sign the same. So this remains as negative 7. This is x squared plus 0x, and then minus our number. So we have 1, 0, negative 32. So I bring down the 1. Negative 7 times 1 is negative 7. 0 plus negative 7 is negative 7. Negative 7 times negative 7 is 49. Negative 32 plus 49 gives us 17. All right? And if we have checked, we can do negative 7 squared, making sure the negative 7 is in parentheses, and then minus 32, which gives us 17. Okay? So, again, if I have it written this way, this is the same thing as saying x equals 2. So, I'm going to keep the sign the same. If it's x plus or minus a number, you change the sign to the outside. If it's x equals a number or f of a number, then you keep it the same. So 2 stays here. This is cube squared, 1, none. So I haven't missed any powers. I don't need any zeros, and it's already in descending order. So 1, negative 4, 5, and 3. So I'm going to bring down the 1. 2 times 1 is 2. Negative 4 plus 2 is negative 2. 2 times negative 2 is negative 4. 5 plus negative 4 is 1. 2 times 1 is 2. 3 plus 2 is 5. So again, if we've done our synthetic division correctly, if I plug in 2 into here, we're going to have 2 cubed minus 4 times 2 squared plus 5 times 2 plus 3. And we get the same exact thing, right? So, oh, I forgot to write how we write these answers. So here, we would write just 17 as our answer, because it says use the remainder theorem to evaluate this. So this is our answer. Here we can write f of 2 equals 5. So there's 2 ways that you can talk about synthetic division. One is where you want the whole quotient, or what you divided, the answer to the division problem is what I'm trying to say. Or I can say what's the remainder, and then you just care about the end number. Now we have another theorem that's called the